Welcome to Ask and Learn.
All right, so here we are given that an is equal to 2 an minus 1 plus 5 times an minus 2 minus 6 times an minus 3. So in this case, n must be greater than or equal to 3, or this equation can't function really. And we have our initial conditions: a naught is equal to 7, a1 equal to 4, and a2 equal to 8. Okay, so we'll start with the roots characteristic equation. And so here we're going to let an equal r cubed. An minus 1 will then be equal to r squared. An minus 2 is going to be equal to r. An minus 3 will then be equal to 1. So we make these substitutes into the given equation, and we end up with r cubed is equal to 2r squared plus 5r minus 6. So we can rewrite this so everything's on one side, and that gives us r cubed minus 2r squared plus 5r plus 6 is equal to 0. Of course, that's going to be minus 5r. And then we will factor. So factoring this, what we end up with is r minus 3 times r minus 1 times r plus 2 is equal to 0. So this gives us roots of 3, 1, and negative 2. Okay, so we'll use those roots to build a solution to the recurrence relation that we have. And so from those roots, we know that the solution will be of the form alpha 1 times negative 2 to the power of n plus alpha 2 times 1 to the power of n plus alpha 3 times 3 to the power of n. And so everything that's raised to the power of n is one of our roots from before. And all the alphas are constants that we need to determine. So we're going to determine them with the initial conditions. And so initially we're given that a naught is equal to 7. And so if we put a 0 in to the above equation, everywhere that there's an n, we end up with alpha 1 plus alpha 2 plus alpha 3. Okay, we also know that a1, which was equal to negative 4, is going to be then equal to negative 2 times alpha 1 plus alpha 2 plus 3 alpha 3. And lastly, a2, which is equal to 8, is going to be 4 times alpha 1 plus 2 times alpha 2 plus 9 alpha 3. So now we just have this system of equations to solve. And so we're going to first start by subtracting the first equation from the second and the first equation from the third. So we're taking a1 minus a naught, and that will give us negative 11 is equal to negative 3 alpha 1 plus 2 alpha 3. Right, and so we did that because it eliminated that second variable. Okay, now we're going to, I see I have a little typo here. There should not be a 2 in this equation. So now we're going to take the, I want to keep writing in red, the third equation, A2, and we will subtract A naught from that as well. And what we get there is going to be 1 is equal to 3A1 plus 8 alpha 3. Okay, and so this works out nice because we can now add these two equations together, and that first variable, the alpha 1, will cancel out. Right, so if we just add these two red equations, we end up with negative 10 is equal to 10 alpha 3. So from that, we know that alpha 3 must be equal to negative 1. So that we know that alpha 3 is equal to negative 1, we can put it into one of the red equations. So we'll get that negative 11 is equal to negative 3 alpha 1 minus two, right? And so that means that negative 9 is equal to negative 3 times alpha 1. So alpha 1 must be equal to 3. And now that we have alpha 3 and alpha 1, we can put them into this very first equation, which says that 7 is going to be equal to alpha 1, which is 3, plus alpha 2, we don't know yet, plus alpha 3, negative 1. Okay, so if we subtract 3 and add 1 to the left side, we get that 5 is equal to alpha 2. And now all that's left is to put it into that black equation at the top. Right, so where we have an alpha 1, we will replace that with a 3. Where we have the alpha 2, we will replace that with the 5. And where we have the alpha 3, we'll just replace that with a negative 1. And then that is our final solution here. An is equal to 3 times negative 2 to the power of n plus 5 times 1 to the power of n plus negative 1 times 3 to the power of n.